Hello, and welcome to our first Analytical Foodies Bite-Size webinar series. This series will provide hints and tips to help you be successful with your multi-residue analysis. My name is Ewan Ross, and I am a Principal Market Development Manager at Waters Corporation, and the topic of this episode will be retention. So what is retention, and how much is enough? To get started, let's consider first some of the benefits of multi-residue analysis. What are the benefits of multi-residue methods for pesticide analysis? Well, they allow us to capture more information in a single analytical run, using a generic sample preparation and chromatography method. This leads to streamlined or fewer workflows, which leads to better asset utilization. This allows a laboratory to have more efficient methods and increase its competitiveness. The better asset utilization improves the profitability by reducing costs. So, what type of column is required for multi-residue pesticide analysis? Well, we need a stationary phase which will allow us to achieve good retention for a range of pesticides with different chemical properties. Whilst we wouldn't be looking to retain highly polar pesticides such as glyphosate in this method, we would still want to retain moderately polar pesticides. Our method may be targeting 500 or more pesticides. So whilst we may have to compromise a little on our chromatographic performance, we need to select the column dimensions and particle size which gives a sufficient peak capacity whilst providing good peak shapes for a wide range of analytes while still achieving our key separations. I have mentioned retention already, but what is retention and how much is enough? In chromatography, our solutes interact with the column stationary phase and should elute after the void time of the column. So retention is the time it takes for the solutes to pass through the column. Typically this is measured from the start of our injection to our analytes detection. The EU SANTE guidelines specify that the minimum acceptable retention time for the analytes should be at minimum twice the retention time corresponding to the void volume of the column. But how do we measure the column void volume? This is an example of the calculation we can use to estimate the void volume of our column. To get a more accurate answer of the column void volume, we need to inject a compound that will not retain on our stationary phase. The void volume, or V, is the volume of a column which is not taken up by stationary phase. To calculate this, we need to take the pore volume of the column stationary phase, which is typically either 0.66 for a fully porous column or 0.49 for a solid core column, in the case of Waters columns. We multiply the pore volume by pi, then multiply by the column internal diameter divided by 2 squared, multiplied by the length of the column. On this slide, we have the example column void volume for a 3 mm by 100 mm fully porous column, and this is estimated to be 467 microliters. Now we have estimated our column void volume. We now need to take our mobile phase into account so that we can calculate our column void time, or T0, which is the time required for one volume of mobile phase to exit the column. If we take the estimated void volume of our 3 mm by 100 mm column, which was 0.467 mils, and divide that by our flow rate, which in this case is 0.5 mils per minute, we estimate our T0 to be 0.93 minutes. This means that any pesticide that elutes before this is not retained. Let's consider again the EU SANTE guidelines. They specify that the minimum acceptable retention time for the analytes should be at minimum twice the retention time corresponding to the void volume of the column. If we take the column void time, or T0, that we calculated in the previous slides and multiply that by 2, we can see our pesticide, in this case methimidofos, is retained, as 2 times our T0 is equal to 1.86 minutes, and our pesticide's retention time is 2.44 minutes. Calculating the retention factor of our early eluting pesticide, methimidofos, is another way to confirm whether or not we have sufficient retention for that analyte. Retention factor, or K, is a measurement of our analyte's retention in relation to the column void time, T0. To ensure that we have enough retention of our earliest eluting analytes, they should have a K of at least greater than 1, but preferably greater than 1.5. If our K value is below 1, then little or no chromatography has taken place, so our separations may be less stable, and there will be a much higher chance of ion suppression for our earliest eluting pesticides when LC-MS is used. Thanks for viewing this episode on retention. More episodes in this bite-sized series are available on waters.com.